We're going to need your calculator today, so if you don't have your calculators out yet, then if you want to get those out. Yesterday we talked about the different types of functions, and we're not going to see all those functions today. Yesterday was just kind of like, okay, here's some of the different functions we could have. We'll see some of those throughout at different times. Pretty much most of those functions we'll spend some time with individually and talk about some of the more particular parts of them, like the vertex and minimums and maximums and things like that. Today, we're going to be really focused on different kinds of functions, but not only with those functions, what are some different things about those functions? And so we're going to talk about, like, where is the interval increasing, decreasing, or maybe constant. We're going to talk about what are the minimum, the maximum, the vertex of a function. And so we'll see some of those functions. Parabolas is going to be a big one that we're going to see today. Maybe a little bit with cubics, maybe the absolute value function, but probably not all of those ones that we talked about yesterday. So to start off with, this was a concept that we talked about briefly in chapter 1. And we said, what is the zero of a function? And we only did it with a linear function, I believe. We didn't do it with any other function. And zeros is going to be a really big topic that we're going to talk about throughout the semester with different types of graphs and different types of functions. And so there's a couple different things that we can do. One of the things that we could do to find the zero of a function is simply just take the equation and set it equal to 0. And because my function is linear, then it's pretty straightforward. We're just going to solve for x. We're going to add 4. We're going to divide by 2. And we're going to get x equals 2. That's the value of x that makes that equation equal 0. Okay, that's really what we're trying to do. Now, if I were to look at the graph of this my y-intercept is -4. My slope is 2 over 1. So we're going to go up 2 over 1, up 2 over 1. And what we notice is my x-intercept is 2, 0. Which is the same value that I got here. So the x-intercept and the 0 are essentially the same thing. We always write the x-intercept as an ordered pair because it's on a graph. We just write the 0. We would say this is the 0 of the function. Okay? So they mean the same thing, but we'll use both of those words pretty much interchangeably, where we'll say this is the 0 or the x-intercept. Sometimes we call it the solution of the function because that's what this is. It's the solution of that function. So a lot of different ways that we might refer to it, but they all essentially mean the same thing. Okay, so we've only seen it with linear so far, okay? And not that we're going to do it with a lot of different functions, but probably the other one we're going to see it a lot with, and we'll get more in depth with it later on in the semester. But today, if I was to give you a quadratic function, later on in the semester we'll talk about all the different ways that we could find the 0 of this function, but for right now, the best and quickest way is to just graph it. So if we graph this function, -1 and 2 were the two places that this is going to cross. So my x-intercepts, we would say, are -1, 0, and 2, 0. If I said, what are the zeros? we would just say x equals -1 and x equals 2. You could write it like this, but one of the things that happens here is that when we write it like this, some people think it's an ordered pair when they see the comma in between, and it's not. It's two separate points, so that can be a little bit confusing. So that's kind of why sometimes I like to write it out as two separate solutions, because that's what they are. They're two separate solutions. But if you write it like this, it's not wrong. Just know that it's not an ordered pair. And once again, what we're saying is if I were to plug these two numbers back in for x, that's what's going to give me 0, right? No matter what it is, that's what we're doing when we find 0, is what values of x will give me 0. That's why we call it a 0. Another function we'll look at real quick here while we talk about zeros. Let's graph this one. Let's see what happens. Should get a parabola. It's still a quadratic equation, so it's still a U-shaped graph. But this graph never crosses the x-axis, right? And so that's an issue because that's what we're looking for. We're trying to find out what are the zeros here. So what do you think we would say about our zeros? And so here's where you have to be careful. There is no x-intercept. And so what we would say here is that there are no real zeros. And for right now, the good news is that we're not going to deal with imaginaries. Down the road, we'll talk about what are the imaginary zeros of this function, but for today, that's not what we're going to be focusing on, okay? So there are going to be zeros to this. They're just not real because it doesn't cross the x-axis. And that'll be something that we'll talk about more in depth later on. So it doesn't have to. It could also come down, and there are times where it could come down, touch the x-axis, and bounce back up. And in this case here, that would be one real zero. So you could have a parabola that has one real zero because it doesn't cross it in two places. Most parabolas, we would think, oh, it's got to cross in two places, and that's probably true. But it could never cross it. It could touch it one time, or it could touch it two times. Those are the three different possibilities when you have a parabola. Okay. On these next one we're going to talk about is three different kinds of things can happen when we have a function. We're going to try to determine where is the function increasing, decreasing, or constant. Okay, an increasing function is where is the function rising or getting bigger, right? If I had a linear equation that was rising forever, then that means it would always be increasing. It's going to increase from negative infinity to positive infinity. But not all graphs are going to do that. So some of the functions that we saw yesterday are going to have different times where they're going to increase, decrease, or be constant. And we haven't really talked about constant a whole lot yet, and I'll show you what that looks like. So here's the first one. If I were to put a parabola here, that reaches its high point at -1,5. We call that the vertex or the maximum point of the parabola. Okay, it's never going to get any higher than that. So as this graph goes from left to right, just like we do anything, we're going to move from left to right. Down here, as I start to move, I'm moving up. right? My graph is increasing until I get to this point, and at this point, it changes direction, and now it begins to drop or fall, okay? And so on the left-hand side of this graph is increasing. It's rising until it gets to that high point. And then on the right-hand side of the graph, now it's changed directions, and now it's dropping or decreasing and going down. Okay? Trying to use D words so you can kind of think about how those are all related with one another. But then it's going to ask us, like, what interval is it increasing or decreasing? Okay? So over here, it's going to go all the way to negative infinity, right? And so on this one, we would say that this graph is increasing from negative infinity all the way to -1. Okay, and we're dealing with x values here. So I'm not going to use the 5. I'm moving from left to right. And when I move left to right, I'm only using the x values. So don't even worry about the 5 here. That just tells me the order pair where it changes. So we're moving left to right till we get to -1. And -1 is now where it begins to drop. And so then we would say that this graph is decreasing from -1 to forever or infinity. The good thing about when we do increasing and decreasing is we don't have to worry about brackets. We're not going to use the bracket symbol because at -1 it's really neither increasing or decreasing. So we're not going to do the bracket for inclusive. We're going to only use parentheses here. Okay. I could give you one that's just the opposite of that. This time it's an absolute value function. It's our v, one of the ones we saw yesterday. This one's just the opposite. As I go from left to right, it starts way up here and it's dropping until it gets to 2. And then at 2 it changes direction and now it starts to go back up. Okay? So it's kind of going in the opposite direction here. This time the decreasing is the first part. And it's going to decrease or drop from negative infinity all the way to the left until it gets to 2, as it moves across the x-axis until it gets to 2. At 2, I call it bounces, right? Because it bounces kind of off the x-axis and it goes back up. And now it's going to increase as it goes from 2 to infinity because it's rising, going up. And so that would be the increasing interval. So we just got to be a little bit careful about how we write that. As long as the graph goes on forever, we might see some graphs that have like endpoints at the end, and it may not go on to infinity on both directions. But in this case, both graphs have errors on the end, so they're going to keep continuing on. Okay, we've seen this function before, but the third thing that could happen is we could have a constant function. And a constant function is our horizontal line. It doesn't go up, it doesn't go down, it's just staying flat, okay? And it's just going to continue to go the same direction all the way through. It's not rising or dropping. So we're going to see some functions that are going to do all three of those, okay? And that's where it gets a little bit different, okay? And it's not necessarily going to be any of the functions that we saw yesterday. It's going to be kind of a piecewise function, kind of like we talked about yesterday, where it's going to be like different pieces and different parts of the graph. So I'm going to show you an example of one of those. We didn't see any yesterday that had like a quadratic with a linear, with a constant. These are just like four completely different parts to what's going on here. And so the way that I kind of like to do this, because the question you're going to see on something like this, where is this increasing? Where is it decreasing? And where is it constant? And it doesn't really matter what order you do those three in, because those are three completely different intervals. And so what I like to do is I like to label each one first of all. So this very first part right here, as I go from the left to the right, what's happening with this first part? It's decreasing, right? It's dropping. So I'm just going to label this part with a D. And then the second part, as I go from this point to this point, and points are where the graph is changing direction. That's why I labeled these points in particular. What's going on right here? It's constant, right? Notice your y values don't change. The y value stays -1 for that whole interval right there. So this would be constant. Okay, the third part, it's going up, right? It's increasing. So I'm just going to label that with an I. And then at that point, then it starts to drop again. So we have two decreasing intervals, one constant and one increasing. Okay, and we're going to label those. So now I just kind of move left to right. This graph continues to go on to infinity, negative infinity, I should say, all the way up. And remember, we're only focusing on the x values here because we're moving left to right. As I move across the number line, we're going from negative infinity until I get to this point right here where it hits its first point. And so it's decreasing from negative infinity to -2. Second interval, we said it's going to be constant from -2 over to 3. And so at constant, we're going to do that. We're going to say -2 to 3. Third interval, it's going to start at 3 and it's going to rise till it gets over to 5. So 3 to 5 would be increasing. And then it's going to drop for that last interval, and so we would say 5 to infinity. We don't necessarily have to put that little U symbol in between. We're just stating all the intervals where it's increasing, decreasing, or constant. Okay. Questions on that one? Okay, another thing that we're going to do with these graphs today is we're going to talk about what we call the relative min or max. So I'm going to give you a function here. We're going to do 4 things here. Okay, really 3 things, but I'm going to show you how the answer is written, and it's a little bit different. And this is how the book is going to express it, so I want you to see how this is going to be written, just so you know that we can call it an ordered pair, but it's going to be expressed a little bit differently. So we're still going to do increasing, decreasing, and then we're going to talk about a min or a max. There are going to be some graphs that are going to have both a minimum and a maximum. We'll show you what that looks like. There'll be some that won't have a minimum or some that won't have a maximum. Okay, so if we graph this one, 4 minus x squared, put it into your y equals. Doesn't have to be a real exact graph. We're just kind of looking for a sketch here more than anything. Sometimes we got to be exact with our graph, but here we're more talking about pieces of the graph than we are focusing on the graph itself. Okay, so let's do the increasing and decreasing first. The point where it reaches its high point is at 0, 4. Okay? Now, if you wanted to find this, this one should be pretty easy to determine just by looking at the graph. But once again, you could go to your calculate feature on your calculator, right? This is what we call a maximum because it reaches its high point. That's the highest it's ever going to get to. It's going to come up, it's going to hit, and it's going to drop. And it happens at 0, 4. So this graph is increasing from negative infinity until it gets over to 0 because it's increasing in that first part. So negative infinity over to 0. And then at 0, the graph begins to drop. So it's dropping or decreasing from 0 to infinity. Okay, this one has a maximum. And we know the ordered pair of that maximum is 0, 4. But the way that we're going to write this four is the high point that it reaches. So when we talk about a minimum or maximum, we're going to talk about the y value of that ordered pair. So it's going to reach a maximum of 4, and that happens at x equals 0. So that's just a little at symbol. X equals 0. And that's how they're going to express the minimum maximum, rather than an ordered pair. It's taking that ordered pair and putting it in a little bit different format. Okay, anybody need help with the calculator? Everybody kind of remember how to do that on their calculators? Finding the minimum, maximum? Okay, if not, let me know, and I'll be glad to show you. But I know that we've done that before, so that's why I'm not spending a whole lot of time here to go through and do that, because I know that's a skill that hopefully you've got from Algebra 2. Told you we were going to see some different functions today that we saw yesterday. Okay, we saw a parabola here just a second ago. We see the absolute value sign, so immediately that should tell me it's going to be a v. Okay, maybe the v opens up, maybe it opens down, but it's going to be a v. Okay, this is the one. We saw this a little bit in chapter 1. Putting this into your calculator, especially for the TIs, you got to go math, num, and then ABS. Make sure you go to the y equals first. Okay. So you got to go y equals. I want to insert that absolute value symbol into my equation so that I can graph it. We're going to graph a sketch of this graph. Once again, I'm not going to get hung up on the graph so much today. We're just using the graph to kind of help us guide everything else. And we're going to answer the same 3 questions we did on the last one. Where does it increase? Where does it decrease? And then what is my minimum and maximum value? Okay, one or the other, maybe both. And I'll show you one that has both here in just a second. Okay, so on this one, our graph is decreasing on the first part as I go from negative infinity all the way over. And then I always like to identify what this ordered pair is. This would be a -3, -5. If you did your minimum value, your left bound, your right bound, and did that minimum value, it should give you -3, -5 on your calculator. So it's going to decrease from negative infinity to -3. And at this point then it bounces and goes back up. So it's going to increase then from -3 to positive infinity. Okay, this one we're going to call it a minimum because this is the low point that it reaches. It will never get below that point. Okay, so that will be the lowest point it reaches, which makes that a minimum. On this one, we don't have a maximum because the graph's going to go up forever and never hit a high point. If you want to write the order pair first, you can, but then we're going to say that it has a minimum of -3, and that happens, minimum of -5, and that happens at x equals -3. So the y value is always your minimum or maximum, and then what is the x value where it hits it at. Okay, so far so good. Calculators, everybody all right? Getting minimum, maximum? Okay, and I know that sometimes, like when we do that, like it might give you some decimals. Like sometimes if you, depending on where you put your cursor at, it might read this as like -3.0000. If you see something like that, just know that that really means -3. Or in some cases, it may say like -2.999999, right? We just got to know that that's really -3. I think it's kind of like a glitch in the TI calculators that they try to get it as close as they possibly can to that actual value, and then when they round it, it rounds like to like a number like that we basically will call that -3. Okay, this last one here. Okay, we're going to do the same 3 things. Where is it increasing? Where is it decreasing? And what is the minimum, maximum value of that graph? Okay, so the first thing we've got to do is we got to put the graph in. Graph's going to look something like that. Okay, I'm going to go ahead and label this 0, -0.8, -7.1. 0.8, -4.9. This is where it gets a little bit tricky. Because we're dealing with decimals, right? So we've got 3 different parts to this graph. Right here it's decreasing. Right here it's increasing. And then it's decreasing again. So we have 2 decreasing parts and we have 1 increasing part. As we go left to right, we're going to go -infinity to -0.8, right? Only x values here. -infinity. And it's going to increase from -0.8 to +0.8. And then it's going to decrease again from 0.8 to infinity. This one has both a minimum and a maximum. Okay, the minimum we're going to say is -7.1, at x equals negative 0.8, and the maximum is negative 4.9, and that happens at x equals positive. On that one, you're going to have to round, right? Because our decimal was a big long decimal. So what you round to, tenth is fine, unless it says round to the nearest hundredth or something like that. Okay, questions on any of that? You guys feel good about that? Once again, and I can't stress it enough, if you need help with the calculator, guys, please let me know, and I will be glad to help you out, okay? I want to make sure you guys know how to use your calculator. If you weren't able to do any of those things or find any of those things on your calculator, now's the time to ask.